Okay, so we have this problem of joint probability uh, mass functions and marginal distributions and all that. So you see, so x can take value 0, 1 and 2 and y can take 0, 1 and 2. Now this is the probability that x takes value 0 and y at the same time can take value 0, which is 1 over 18. So, and this indicates the probability that x takes value 1, y 0, and this indicates x takes 2 and y 0, and so on. Now here, what is the probability that y takes value 0? We sum all this row wise and write it here. So I have just indicated here 1 over 18, 1 over 9 and 1 over 6. So you calculate this in calculator and put it here. Similarly, what is the probability that y takes value 1? And this is the sum. So it's the same way. And similarly, what is the probability that x takes value 0? So you sum all these things and put it here. And similarly for x and y. So these are called marginal probability of x this way. And these are called marginals probability of y. So let's solve this problem A. So we have to compute probability of 1 less equal to x less equal to 2 and y is greater equal to 1. Now look at this. So this can happen this way. Probability of, so x less equal to 1 means, so this can think of x belongs to 1 and 2, right? And y is greater than 1, so that means y also belongs to 1, 2, right? This can happen. So in other words, this can happen this way. Probability that x equal to 1 and y equal to 1 plus probability that x equal to 1, y equal to 2 plus probability x equal to 2, y equal to 1 plus probability x equal to 2, y equal to 2. So you watch this table and you put the value. What is the probability that x equal to 1, y equal to 1? So x equal to 1 and then y equal to 1. So x equal to 1, y equal to 1 is this 1 over 18. So for this we write 1 over 18, and then for this x equal to 1, y equal to 2. So x equal to 1 and y equal to 2. So this 1 over 6. So 1 over 6, and then x equal to 2, y equal to 1. X equal to 2, y equal to 1 is 1 over 9, and then x equal to 2, y equal to 2. x2, y2 is 1 over 18. So if you add these things, and that's the answer. Okay, now B is obtain marginal probability mass function of x and y. So in other words, probability mass function for x is, you can think of that x is when x equal to 0, then I mean x can take value 0, x can take value 1, and x can take value 2, right? So what is the probability that x can take 0? So x can take 0 with this probability, sum 1 over 18, 1 over 9 and 1 over 6. So we just add this thing. So 1 over 18 plus 1 over 9 plus 1 over 6. I am not writing the answer because I do not have calculator, and so you just add this and That's the probability for x equal to 0. And for x equal to 1, you add these things, 1 over 9, 1 over 18, and 1 over 6. So 1 over 9 plus 1 over 18 plus 1 over 6. And for x equal to 2, 1 over 6 plus 1 over 9 plus 1 over 18. Similarly, for y, you can write p of y of y so y can take value 0. What is that? You can see from the table 0, this sum, right? I have indicated it's there already. 1 over 18 plus 1 over 9 plus 1 over 6. 1 over 18 plus 1 over 9 plus 1 over 6. And for 1, this sum 1 over 9, 1 over 18, 1 over 9. 1 over 18 plus 1 over 9 plus 1 over 9. Y equal to 1 and y equal to 2. 1 over 6 plus 1 over 6 and 1 over 18. That's it. So these are the probability mass functions for x and y. And what was the third problem? And C, are x and y independent? So you know that independence, so when x and y are independent, we need to check to show that x and y are independent. We need to check that probability of x equal to some xi and y equal to some yj can be written as product of these two. So x equal to xi times probability of y equal to yj. So for example, and that has to be for all I and for all j. Now I can take value, this can take value 0, 1 and 2. J also can take value 0, 1 and 2. So let's check what happens for probability of x equal to say 2 and y equal to say 1. So probability of x equal to 2, y equal to 1 is x equal to 2, y equal to 1, say 1 over 9. Okay. So now this is from the table. From the table you can see. Now what is probability of x equal to 2? Probability of x equal to 2 you can see from here. Okay, this is the probability and I ask you to calculate this, and probability of y equal to 1, that you calculate from here. This is the probability of y equal to 1. Now suppose probability of x equal to 2, after calculation you get some number a, and probability of equal to 1 you get some number b. Now if a times b is this 1 over 9, then not equal to 1 over 9, then you can tell that x and y are not independent. They are not independent.